Good afternoon, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on discrete Fourier transform, that is Introduction to DFT. First, we can see the empathy part of discrete Fourier transform. Signal defects. Identifying defects in the signals is crucial. Information extraction. Frequency domain information needs to be extracted. Limitations. DFT is continuous, making it impartial to computation. Spectrum analysis is a requirement. Conversion time from time domain into frequency domain, it takes time consuming. And then properties, real world signals are infinite and discrete. Digital analysis, frequency analysis is needed on digital machines. Next one, DFT is a process. First, we can identify the Fourier series and then Fourier transform, discrete Fourier series and discrete time Fourier transform. Finally, we can computate all the process. We can get the discrete Fourier transform sequence. Next one, Fourier coefficients representation is the conversion from the time domain into frequency domain. While we taking the Fourier transform of S of t, we can get S of f. First diagram represents the Fourier transform of a function x of t and then transform of a periodic summation S of t, that is Fourier series coefficients, and then transform the periodically sampled S of t in terms of discrete time Fourier transform. Finally, they can convert it into both periodic sampling and periodic summation, that is nothing but discrete Fourier transform. Why we are calculating f of t means it is a fast Fourier transform to computation of DFT with reduced number of calculations. Next one, discrete Fourier transform. For a discrete time sequence, we have defined two classes of Fourier transforms: discrete time Fourier transform, discrete Fourier transform. Discrete time Fourier transform has infinite duration. Discrete Fourier transform has finite duration. Next one, DTFT and inverse DTFT. X of omega is equal to DTFT of x of n, which is equal to summation n is equal to minus infinite to plus infinite x of n into e power minus j omega n. Inverse DTFT ID DTFT of x of omega is equal to 1 by 2 pi integral over minus pi to plus pi x of omega into e power plus j omega n into d omega. Next one, discrete Fourier transform. It is the conversion from the time domain into frequency domain. Next one, this is the another representation of the signals in terms of Fourier transform. First, time domain signals with respect to time and amplitude, which can be mentioned it as 1 kilohertz, that can be converted into frequency domain in terms of 1 kilohertz. Sample, the same signal can be converted into two different periodic signals, that is written by t by 2, another t by 2, that can be converted into frequency domain in terms of 2 kilohertz with respect to amplitude and frequency. Next one, discrete Fourier transform. DTFT x of omega is periodic with a period of 2 pi. The frequency omega is the digital frequency. It is limited to the interval minus pi to plus pi. And digital frequency omega is the normalized frequency relative to sampling frequency as defined as omega is equal to 2 pi f. F can be defined in terms of sampling frequency as f by fs. The representation can be shown by minus f by sf by 2 to plus fs divided by 2. That is nothing but here 1 period of x of omega. It means minus pi to plus pi. Next one, this is the another time domain to frequency domain representation in terms of n. That is, first representation can be represented as x of n, that is nothing but discrete representation that can be converted into frequency domain. We can represent as x of e power j omega to omega. It can be represented as omega, 2 omega and then 3 omega, which can be represented in terms of frequency domain. Next one, discrete Fourier transform. It a finite sequence, that is nothing but x. So x can be mentioned as up to 0 to n minus 1. And DFT means we can inverse DFT is nothing but DFT of x of 0 to x of n minus 1. See, discrete Fourier transform can be defined as x of k is equal to summation n is equal to 0 to n minus 1, x of n into e power minus j2 pi kn divided by capital N. Next one, inverse discrete Fourier transform. Small x is equal to IDFT of capital X. Small x varies from 0 to n minus 1. x of n is equal to 1 by n, summation k is equal to 0 to n minus 1 x of k into e power plus j 2 pi k divided by capital N. Next one, discrete Fourier transform. See, DTFT and IDFT forms the transform pair. When x of n can be applied to DFT, we can get it as a capital X of k. Same capital X of k that can be applied to inverse discrete Fourier transform, we can get small x of n. It both DFT and IDFT forms the transform pair. Next one, this is the representation of DTFT and DFT. First one, the digital signal can be given in terms of 0 to n minus 1, and then DTFT sequence is can be represented by 0 to 2 pi, and then DFT sequence it can be represented in terms of discrete time 0 to 2 pi by n to n minus 1. This is the applications of DFT. It is used in spectrum analysis, image processing, signal processing, sound filtering, data compression, partial differential equations, and large integrated integer multiplication. Next one, this is the mind map of discrete Fourier transform. First, we can get the sort sequence DFT, compute DFT for a sort sequence, spectrum prediction, predict spectrum for given signals, image compression using JPEG standard, biomedical signal diagnosis using spectrum analysis, frequency identification of a signal, and then speech and audio processing applications, spectrum analysis in communication systems. Next one, we can see the assessment. Define DFT. DFT can be defined as x of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi k n divided by capital N. What is mean by IDFT? Inverse discrete Fourier transform can be defined as x of n is equal to summation k is equal to 0 to n minus 1 x of k into e power plus j 2 pi k n divided by n. Give some applications of discrete Fourier transform. It is used in spectral analysis, image processing, audio processing, and speech signal processing, partial differential equations, etc. The DTFT of four sequences having infinite duration. The digital frequency omega is the normalized frequency relative to the sampling frequency defined as omega is equal to 2 pi f. In terms of sampling frequency means 2 pi f divided by fs. Define DTFT pair. DTFT pair means the DTFT and IDFT forms the transform pair. When x of n is applied to DFT, we can get as x of k. Then x of k can be applied to IDFT, we can get x of n. Thank you.